This is the problem of geometry based on triangle. Here we have an isosceles right angle triangle, the length of whose sides are 4, 4, 4 root 2 units. So this is the triangle whose sides are 4, 4, 4 root 2. Find the minimum length of the cut which can divide the triangle into two parts of equal area. So we have to make a cut in such a manner that length of the cut is the minimum possible and it divides the triangle into equal part of area. By simple observations, if we drop a perpendicular from B to side AC, it will divide triangle into equal part of equal area, and length of BD will be 4 into 4 upon 4 root 2, which is 2 root 2, and this is the length of the maximum cut that can divide the triangle in two equal parts, which means our answer should be less than 2 root 2. If we look at the first option, which is exactly 2 root 2, so it cannot be the answer. Now coming to second option, it is more than 2 root 2, so it is also not a possible answer. Now we have two figures. Value of first figure would be 4 into root 2 is approximately 1.42, and 1.42 minus 1 would be around 0.41, and 0.41 would be around 0.65. So value of, or approximate value of third option is around 2.6, and if we look at the option D, it is around 1.3. One thing should also be noted here, our cut of the minimum length would not be very less compared to 2 root 2. It has to be very near or close to 2 root 2, and if we look at options C and D, option C is close to 2 root 2, but option D is very far from this figure, so option D in that way cannot be our answer. Therefore option C is the correct answer. This is the way we can solve this problem in exam without doing normal stuff. But if we go by concept, then let's draw the line PQ. P cuts AB at P cuts AB and Q cuts AC. This angle will be 45 and this will also be 45. Area of this triangle, that is ABC, will be 4 into 4 by 2, which is 8. So area of triangle ABC is 8, and area of triangle APQ will be 1 by 2 AP into AQ into sine 45. And we know that area of triangle APQ is half of the area of triangle ABC. Therefore 4 is equal to 1 by 2 AP into AQ into 1 by root 2. From here AP into AQ will be 8 root 2. Now applying cosine formula in triangle ABC, will get PQ square equals AP square plus AQ square minus 2 AP into AQ into cos 45. AP into A cube is equal to 8 root 2. So P cube square will be AP square plus AQ square minus 2 PQ, which is equal to A AP into AQ, which is equal to 8 root 2, and cos 45 is 1 by root 2. So PQ square will be AP square plus AQ square minus 16 on further simplification. Will get PQ square equals AP minus AQ whole square minus 16 into 2 root minus 1. We have to minimize the value of PQ which means we have got to minimize the value of AP minus AQ whole square. This is a square, which means it cannot be less than 0. Therefore the minimum value of AP minus AQ will be 0. In that case PQ will realize its maximum value, and it will be PQ square equals 16 root 2 minus 1. Therefore PQ is equal to 4 root 2 minus 1, which is option C.